वेरी गुड मॉर्निंग टू ऑल ऑफ यू. हाउ आर यू? कैसे हो आप सब लोग? सो व्हाट वी वर टॉकिंग अबाउट? We were talking about the chemical kinetics, and in the last lecture we have seen what we have seen in the last lecture. We have seen the introduction to the chemical kinetics. What is the difference between kinetics and thermodynamics, that we have seen, correct? And then we have seen different terms involved in chemical kinetics, that is rate law, rate of reaction, order of reaction, molecularity of reaction, and then we have seen the difference between order and molecularity. We have also seen how to find out the order of reaction, how to find out the molecularity of the reaction. Yes or no? So with this we will start today's lecture. Today we will see the different factors that are affecting on the rate of reactions. So basically in this chapter we will talk about the rate of reaction, that is speed or velocity of reactions, which factors are there and that can alter the rate of reaction, that also we will see. Then we will see the integrated rate law for different order of reactions. We have seen the order may be zero order, first order reaction, second order reactions. So different orders are there, third order reactions are also there. Okay, so we will derive an integrated rate law equation for that particular order in today's lecture. Very good morning to all of you. In today's lecture we will see, or we will start with the integrated rate law for zero order reactions. Before going to the integrated rate law, we will see the different factors that affects the rate of reaction. Okay, so we will start the today's lecture. So this is your lecture number 2 of chemical kinetics. ठीक है, ये आप लोगों का लेक्चर नंबर 2 है. So we'll start with the factors. See here, the today's topic, write down this topic: factors affecting the rate of reaction. There are different factors which alters the rate of reactions. Which factors are there? See here, these factors are there. First factor is temperature, which is important factor, temperature. Okay, so this temperature affects the rate of reaction. Then concentration of reactant also there, this is also important. Concentration of the product is also there. So concentration of reactant, whether it is low or high, in that also the rate of reaction is depend. Then presence of catalyst, which is also important point. Then particle size of reactant, this is important when there is a solid reactant. When there is solid reactant is there, then it is also important factor, that is particle size of the reactant. So the rate is depends upon the temperature, concentration of reactant, concentration of product, presence of catalyst, and particle size. So these 5 factors are there on which rate of reaction is depend. So these 5 factors that affect the rate of reactions, how, that we will see one by one. Okay, so let us start with the first factor, that is temperature. Here, the increase in temperature usually increases the rate of reaction. This is very generalized statement. This is very generalized statement. This statement it is applicable to almost 99.9% chemical reactions. There are some reactions in that case increase in temperature decreases the rate of reactions. There are some reactions also, but generally the increase in temperature usually increases the rate of reactions. Why it is increases the rate of reactions? Because some reactions they requires energy, they requires heat, or they requires energy to form a activated complex. So to form a activated complex, energy is required. That's why temperature is very important factor. Okay, so how it affects? For example, see, some reactions are there. See, this is a reactants and it forms a product at room temperature. There are some reactions, that reactions can form a product at room temperature. ठीक है. Then there are some reactions. For example, a reactant forms a product at 50 degrees Celsius. At 50 degrees Celsius. So these kinds of reaction, they do not go at room temperature, or at a room temperature for such reaction rate is very slow. Okay. So next is, for example, this third kind of reaction. This is first, this is second, and this is third. Reactant forms a product at 200 degrees Celsius. That means at room temperature there is no reaction. At a room temperature no reaction is there. Okay. So to form a product, such kinds of reaction requires very high temperatures, such as 200 degrees Celsius also. So before or to knowing this reaction, now you can realize that the temperature is very important factor. Okay. So generally what happens, if we increase the temperature by 10 degree, then the rate of the reaction increases by 2 or 4 times. For example, if you increase this is also a generalized statement. If you increase the temperature of any reaction, then the rate of that particular reaction increases by 2 to 4 times. See, it is observed that 10 degree, not 100 degree, 10 degree increase in temperature, the rate of reaction increases by 2 to 4 times. This is very generalized statement. So the temperature is also important factor. Temperature affect, or temperature increases the rate of reaction. So rate of reactions is dependent on temperature also. This is the first point. Then in kinetic studies, for example, if you are doing kinetic studies, for example, if we are doing a kinetic studies, temperature of such reactions has to be kept constant. अगर आप लोगों को किसी रिएक्शन का रेट फाइंड आउट करना है या काइनेटिक स्टडी फॉलो करना है, then in that case you have to keep the temperature of that particular reactions by a you have to keep the temperature of such reactions constant. ठीक है. So this is first factor. Then second factor is concentration of reactant. Second factor is concentration of reactant. See here, concentration of reactant. It is observed that if you have pen notebook, you can write down these factors, which is very important. Exam में इसके ऊपर question रहता है for 2 to 4 marks. ठीक है. So second factor is concentration of reactant. It is observed that the rate of reaction is directly proportional to the molar concentration of reacting molecules. It is observed that the rate of any chemical reaction is directly proportional to the molar concentration of reactant molecule. For example, if you see here, I will plot a graph here. For example, here concentration is there, here concentration is there, and here reaction progress is there. Reaction progress is there. Okay. So on y-axis concentration is there, and on x-axis reaction progress is there. It may be time or whatever factor is we are considering, that factor is there. And initially we will write here for reactant. Initially there is 100% reactant is there. Okay. Initially क्या है? We have 100% reactant, and as reaction goes on, what happens? The concentration of reactant goes on decreasing. Concentration of reactant goes on decreasing, and at one point it will remains constant. Okay. So this is the reactant. This is in case of reactants. And another factor is also there, concentration of product. The rate of reaction is also altered by the concentration of product. So it at the zero time, or at initial time, the rate of the concentration of product is 0, and as reaction goes on, their concentration is increases, and at some point it becomes constant. So it is for product. So it is for product. So by knowing this graph, you can understand the concentration of reactant is also important factor. Then the rate of reaction is also altered by the concentration of product. How it is altered? So product form again reforms the reactant. So in case of reversible reactions, means once A goes to B, then again B goes to A. So in that case what happens? The rate of reaction will get decrease. So क्या होता है in first case? A, that is reactant, forms a product B, and again that product reforms the product A. So it is possible in case of reversible reactions. Then second case, product catalyze or inhibit the reaction. So there are some product, they act as a catalyst. After forming that product, what happens, that product also act as a catalyst and the rate of reaction increases rapidly. The rate of reaction increases rapidly. Such reactions is called as autocatalyzed reaction. Such reaction is called as what? Autocatalyzed reaction. Autocatalyzed reaction means in those reactions, in these reactions, product form is acting as a catalyst. In those reaction, product form is acting as a catalyst and the rate of reactions increases rapidly. Second case, what happens, the product form, whatever the product form, which inhibits the reactions. Product form हो रहा है and that product inhibits the reaction. In such cases, what happens, the rate of reactions decreases. In such case of reactions, rate of reaction is decreases. So the concentration of product also alters the rate of reaction. This is the third point. Then fourth point is presence of catalyst. You know that catalyst increases the rate of reactions. Catalyst increases the rate of reactions. So what is this catalyst? Catalyst is a third substance other than reactants. Catalyst is a third substance other than reactants may alter the rate of reaction. It is called as a catalyst. So catalyst alters the rate of reactions. Okay, catalyst alter the rate of reaction. So what is this catalyst? Catalyst is any substance that alter the rate of reactions without involving in the reactions. And अगर वो reaction में involve हो रहा है, so at the end of reaction again it is regenerated. That substance is called as a catalyst. Now how this catalyst increases the rate of reactions, that we will see. How this catalyst increases the rate of reactions. You know that I have discussed this diagram in first lecture also. For example, this is your y-axis and this is your x-axis. On y-axis energy is there, on x-axis reaction coordinates are there. Okay, so for example, these are your reactants initially and they forms a activated complex and again they forms a product. So this peak is called as a activated complex. So what happens, first reactant forms an activated complex and again that activated complex breaks into the product. So activated complex formation is there and the energy between reactant and activated complex, the energy between reactant and activated complex is called as the energy of activation of that reaction. It is called as a energy of activation of that particular reaction. So in presence of catalyst, what happens? In presence of catalyst, what happens? Catalyst, what is the role of catalyst? Catalyst provides the alternate route. Catalyst provides alternate path for the reactions to form a activated complex, and that alternate path, it is a low energy path. That alternate path or alternate route, it is a low energy path. For example, if you see here, in presence of catalyst, what happens? The activated complex forms here only. So this is energy of activation. This is energy of activation with catalyst. So what is the role of catalyst here? Catalyst provides the alternate path or alternate route to form an activated complex, and that alternate route is a low energy route. So in presence of catalyst, energy of activation is low. In presence of catalyst, energy of activation is low, and I have told you energy of activation is inversely proportional to the rate of reaction. If high energy of activation, rate of reaction is low. Low energy of activation, rate of reaction is high. So this is first case that we have seen. This is the energy of activation without catalyst. This is energy of activation without catalyst, and this low energy of activation is with catalyst. So in presence of catalyst, what happens? Energy of activation is get reduced, and as the energy of activation is get reduced, the rate of reaction will increases. That you know very well, because energy of activation is inversely proportional to the rate of reaction. So in presence of catalyst, rate of reaction increases. This is the fourth point. Then fifth point is particle size of reactant. fifth point is particle size of reactants. Smaller the particle size of the reactants, faster the reaction rate. For example, if one of the reactant is in a solid phase or a solid state, क्या है कि दो reactants है आपके पास, and out of that two reactants one reactant is in solid form and another one is liquid form. So solid form के जो particles है, if that particles are smaller, then the rate of reaction is higher. So how this rate of reaction? Because smaller the particle, higher will be the surface area. Smaller the particle, higher will be the surface area, and higher agar surface area ज़्यादा है, then the rate of reaction is also faster. So these five important factors are there, or we can say factors are there that alters the rate of reactions, or the rate of reaction is depends upon these five points. Which 5 points we have seen? The first we have seen the temperature, then we have seen the concentration of reactant, then we have seen concentration of product, then presence of catalyst and particle size of the reactants. This particle size of reactant is important in case when one of the reactant is present in solid state. Okay, have you understood this? Then we will go to the integrated rate law expression. आप लोगों को समझ में आया क्या factors affecting on rate of reaction? Then we will go to the integrated rate law expression, which is very important. Please tell me, have you understood the factors affecting on rate of reaction? Then we will go to the integrated rate law expression. Nutan, only Nutan is saying yes sir. Okay, chalo Nutan ko samajh mein, Sabha also, Aishwarya is also saying yes sir. Okay, good. So now अगर आपने पेन नोटबुक नहीं लिया है तो लेके बैठ जाओ, because in these sections a lot of mathematical expressions are there and you need to have the pen and notebook. So take pen and notebook and write down what I am saying. Okay, because a lot of derivations are there, lot of mathematical terms are there. For that you have to write it down. Okay, so we'll start with integrated rate law expressions with zero order reactions. These zero order reactions are very uncommon. But there are some heterogeneous reactions which have their order as zero. Okay, there are some heterogeneous reactions means the reactants are in different phase. Reactants and catalyst, they are in different phase. That is called as the heterogeneous reactions. So in case of these zero order reactions, please write down this. In case of the zero order reactions, the rate of zero order reactions remains constant. The rate of zero order reactions remain constant and it does not changes with time. So the rate of reaction is does not depends with the time. It is also independent of the reactant concentration. Okay, so you write down this statement: the rate of zero order reactions remains constant, it does not changes with time, and it is also independent with the rate of reaction. So first of all we will take a reactions. For example, say this reactant A is called as a reactant, goes to the product. Very simple generalized equation, and for these reactions you know how to write down the rate equation. In these reactions you know how to write down the rate equation. See here, the rate is equal to minus d concentration of reactant A by dt. Why d by dt? Because very small change in there, because very small change in concentration of reactant A is takes place. And why negative sign? Negative sign indicates the concentration of reactant A goes on decreasing. Why negative sign we have given? Because of the concentration of reactant A is goes on decreasing. So in this way you have to write down the rate. And in another form, rate law, how will you write? R is equal to this small r is indicated, or this rate is indicated by small r, K0 concentration of A0. K0 concentration of A0. What is this K0? K0 is rate constant for zero order reactions. It is a rate constant for zero order reaction. K0 indicates rate constant for zero order reactions, and concentration of A0 indicates it is a zero order reaction. It is a zero order reaction. Understood how to write down the rate for these different order reactions? Rate is equal to negative d concentration of A by dt, or R is equal to K0 into concentration of A0. K0 indicates the rate constant for zero order reactions. And why this zero I have written here? Because it is a zero order reactions. Because it is a zero order reaction. Please remember this. Okay. Then we can write down this also, minus, if you equate these two equations, then you can have minus d concentration of A by dt equals to K0 into concentration of A0. If we equate this equation, we can have this thing. Okay. Then next is concentration of minus d concentration of A by dt is equal to K0, because you know that, because anything raised to 0 is equal to 1. This is mathematical rule. This is mathematical rule. Anything raised to 0 is equal to 1. So A0 will become 1. So 1 into K0 will become K0. So give the name this reaction as a equation 1. So this is our equation 1. Okay. Minus d concentration of A by dt is equal to K0, because of A0 is equals to 1. Then if A is the initial concentration of reactant A, this is our reactant A, and A is the initial concentration of that reactant A, and if X is the number of moles of product form. So kya hai? For example, we have the concentration of A is small a and concentration of product form is X at time t. At a time t, kya hua hai? After some time, for example 5 or 10 minutes, what happens? The X number of moles of product form from the A at a time t. Then how much concentration of unreactant of A at that time t? So A minus X, क्या है? A में से X प्रोडक्ट फॉर्म हुआ है, तो कितना बचा होगा? अनरिएक्टेड कितना होगा? A minus X, क्योंकि X तो प्रोडक्ट फॉर्म हुआ है किसमें से? A में से. So the concentration of unreacted reactant A at time t will be A minus X mole, So we will substitute the above value in equation 1. So we will substitute the value of equation 1. So here minus d, the concentration of reactant A which is remains unreacted is A minus X by dt, and the concentration of product form. So why negative sign is there? Because the concentration of reactant is decreases, and we have I have not given negative sign here. So that means d concentration of X by dt is equal to K0. This is your concentration of product form. That's why it is positive sign. So d concentration of X by dt which is equal to K0. So give the equation number 2 for this equation. Equation number 2 है हम लोगों का. समझ में आया कैसे? This is your, why negative sign is? Because this is your reactant rate and this is your product rate, and by equating this equation we can have d by dt X is equal to K0. Then rearrange the equation 2. So we'll rearrange the equation 2. This equation we will rearrange. What we will do? We will take this dt into this side, that is right hand side. So dx equals to K0 dt. क्या किया हम लोगों ने? We have shifted this dt from this side and give the equation number 3 for these reactions. Give the equation number 3 for this reaction. Okay. Then integrate the equation 3. Now what we have to do? This is a mathematical part. This is a mathematical part. We have to integrate the equation 3. ये जो equation दिख रहा है ना आप लोगों को, that equation we have to integrate within the limits. Within the limit कौन से? Within the limits t is equal to 0 to t is equal to 2. This is your time limit. So starting time limit is 0 and end time is t is equal to t. For say for example 5 minutes, 10 minutes, जो कुछ भी हम लोगों ने decide किया है वो time. For this is the limits for time. This is the limits for time, and x is equal to x. This is your product. At a time t, x will be at a time t0, x will be x0 at a time t. That means the reactions abhi start in y. At that time x जो कि प्रोडक्ट का कॉन्सेंट्रेशन है, प्रोडक्ट के नंबर ऑफ मोल्स है, वो कितने होंगे, 0 ही होंगे एट अ टाइम t. x will be 0 and at a time at a time 0 t is equal to 0, x will be 0 and at a time t x will be x for the product concentration x. After integrating the equation we will get, so we will integrate this equation within the limit, this equation we will get. So integration dx, x is equal to 0 to x is equal to x equals to integration here t is equal to, we will integrate with respect to time, so t is equal to t0 to t is equal to t k0 into dt. Now here k is what, k is rate constant, it is a rate constant for zero order reaction, so it is a constant, we will take that constant outside the integration. So after taking k0 outside the integration we will get k0 into integration t is equal to 0, t is equal to 0 to t is equal to t dt. So we have integrated this equation. So after integrating, what we will get, the concentration of x 0, that is lower limit, and this is upper limit, equals to k0 concentration of t, lower limit is 0, upper limit is t. So by subtracting lower limits from upper limit we will get, so x minus 0 will be x, so we will get x k0, t minus 0 will be t, which is x is equal to k0 t. Call this equation number 4, and this is our integrated rate law equation for zero order reactions. This is our integrated rate law equation for zero order reactions. Please remember this, very simple है zero order reactions का, first and second order reactions के थोड़े complicated है, ठीक है. So we have get the integrated rate law equation for zero order reactions, x is equal to k0 t, ठीक है. Then we will see the characteristics of zero order reactions. We will see the characteristics of zero order reaction, and first characteristic is units of zero order reaction. First characteristic कौन सी है, unit of zero order reaction. So we have this equation which is a, we know that x is equal to k0 into t, this is our integrated rate equation for zero order reactions, ठीक है. Then we will rearrange this, k0 is equal to x by t. So क्या किया हम लोगों ने, ये जो t यहाँ पे मल्टीप्लाई था, इधर जाने के बाद क्या हो जाएगा, वो डिवाइड हो जाएगा. So k0 is equal to x by t. So now here what is x, can anybody tell me what is x and what is t in this equation? We have rearranged that equation for k0, which is integrated rate equation for zero order reaction. X is equal to k0 by t, which is equal to k0 equals to x by t. And in this equation, what is x and what is t? Tell me. What is x in that equation? What is x and what is t? Tell me. X is what? X is concentration of product form. So x term क्या है? Concentration है. X is reactor. No, Nutan. Chaitanya, correct. X is the product and T is time. Correct. Very good, Chaitanya. X is the concentration of product form and T is at a time T. So here, if you see here, K0 is equal to concentration by T. K0 is equal to, we will derive. Correct. Very good, Sabha. We will deriving the units for zero order reaction. हम लोग क्या देख रहे हैं? हम लोग zero order reactions का unit derive कर रहे हैं. So K0, which is a rate constant for zero order reactions. You know that this is a rate constant. It is rate constant for zero order reaction. This x is what? It is a concentration divided by time. So K0 is equals to, concentrations is generally expressed in moles per liter. because we are taking this concentration in molar. Concentration of reactants and products, they are in molar, so concentration term is moles per liter, and generally time in SI SI unit, we represent time in second. So the units for zero order reaction is moles per liter per second. What is the unit? Here I will write moles per liter per second. This is the unit for zero order reaction. Moles per liter per second. You can write this also, you can write this also. So this is the first characteristics of zero order reactions. How we have derived? We have taken the integrated rate law for zero order reaction, which is x is equal to k0 by t. We have arranged this equation in terms of rate constant for zero order reaction, that is k0 is equal to x by t. So k0 is, what is x? It is a concentration of product form. What is t? T is a time, and concentrations are generally expressed in moles per liter and in times in SI unit in second. So unit for that reaction is moles per liter divided by S. So we can write this moles per liter per second. So this is the unit of this reaction. Then second term is half-life period, which is denoted by T half. This is also very important characteristics. T half. What is half-life period? What is half-life period? Half-life period is a time. Half-life period is a time which is required to complete half of its initial concentration. It is called as a half-life period. For example, in a reaction A goes to B, at a time T, half of the reactant A has converted into the product. That time T is called as a half-life period for that reaction. Correct? Understood? What is half-life period? Time required to complete half of its initial concentration is called as a half-life period. For example, here I will write here a reaction A goes to B. So at a time T is equal to 0, reactant A is 100% and reactant B is 0%. And at a time T is equal to half, this A is present 50% and B is formed in 50%. Okay, so this time is called as a half-life period. The time which is required to complete half of its initial concentration is called as half-life period. So when T is equal to T half, A is equal to, which is the concentration of reactant at a time T half, is A by 2, and this is the X, which is a concentration of product form, will be A by half. So at a time T half, the reactant and the product, they are present in 50-50%. That time is called as a half-life period. So here we will take again the integrated rate law equation for zero order reaction. X is equal to k0 into T. Okay, so we will put this value. X is A by 2 and T is T half. So we will put this value. X is equal to A by 2 equals to k0 T half, and we will rearrange it. In terms of T half. So T half यहाँ पे है, इधर जाने के बाद क्या हो जाएगा? T half is equals to A by 2k. So this is the half-life period for zero order reaction. This is half-life period for zero order reactions. What is half-life period? The half-life period is a time which is required to complete half of its initial concentration. This is the second most important characteristic of zero order reactions. First we have seen units, second is half-life period. First हम लोगों ने क्या देखा था? Units देखे थे. Second कौन सी है? Characteristics, half-life period. Then we will see the third. Third is nature of graph. Nature of graph is also very, very important. So by this nature of graph, we can find out the slope. Once you get the nature of graph, then you can find out the slope, and from slope you can find out the k0, that is rate constant for zero order reactions. So this is equation. X is equal to k0 by T. We know that now very well. This is your integrated equation for zero order reaction, which indicates that if the graph of X versus T is plotted, this X versus T graph, if you will plot this graph, then it should be a straight line passing through origin with a slope equal to k0. For example, if we plot a graph, and x versus t, and this x we will take on y-axis. So here on y-axis x is there, and on x-axis time t is there. This is your graph of zero order reactions. On y-axis we have plotted x, this x we have plotted, and at x-axis time we have plotted this. So this graph indicate that the line should be straight line passing through origin. So line is straight line passing through origin, and if you take slope for this line, which is equal to k0, so by slope you can find out the k0, and k0 is nothing but the rate constant for zero order reaction. This is what rate constant for zero order reaction. So by plotting the graph of x versus 2, you can find out the value of any zero order reactions. We can find out the k0 for any zero order reactions by plotting the graph, that is x versus t. So in this way we have finished the factors affecting on the rate of reaction. Then we have finished the integrated, or we have derived the integrated rate law for zero order reactions. So I think today we'll stop here. In the next lecture, that is tomorrow, we will start the integrated rate law for first order reactions. Today we will see the integrated rate law for first order reactions. We will derive one equation, that is integrated rate equation for first order reaction. Then again we will see the characteristics of the first order reaction. In that we will see the units, then we will see the half-life for first order reaction, then we will see the nature of graph for first order reactions. Today we will stop here. If you have any problem, then you can ask me. I will give 5 minutes for that. Okay? Yes, if you have any problem, you can ask me. Yeah? No problem? Rupesh Kumar is saying yes sir, thank you. Okay, that means no problem, you have understood the lecture today. So I will active the link for your attendance. Give the attendance within 5 minutes. After 5 minutes that attendance sheet, I will inactive that attendance sheet. Okay? So Rupesh Kumar is saying no sir. Okay, chalo. So Nutan is also saying no sir, no problem. I have activated the no problem. Thank you sir. Chaitanya is also saying no problem. Okay, so I activated the link for your attendance. Akriti Singh is also saying no problem. Okay, chalo, no problem. So please give your attendance. I have activated the link. That link will be open only for 5 minutes. ठीक है? चलो. So shall I stop here now? Shall I stop here? Yes or no? Okay sir, Alan is saying okay. Chalo. Chaitanya is also saying okay. Chalo. So bye bye, take care, have a good day.